Hello, welcome to Math 1324. This is Chapter 10, Section 1, Example 4, I believe. In this example, we want to know, does the following rule define y as a function of x? That is terrible grammar here. You know what? Let's do this. Make it to where you'll never see this. Ever, ever, ever. Fantastic. No one has to know. Don't tell Miss Ortega. Okay, so does the following rule define y as a function of x? Okay, so here's the thing. We're not given a set of coordinates here. In the last couple, we were given a set of coordinates. Here, we don't have one. And the question is it a function of x? And I can actually just look at this and tell you, yes, this does in fact define a function of x. And here's why. Look at the y variable. It's actually the y variable that matters when we have something like this. What's the exponent on the y? The exponent here is 1. It's an understood 1, but it's 1 nonetheless. If we had y to the first power, y to the third power, y to the fifth power, so on and so forth, any of those odd exponents, that tells me that yes, it is in fact a function of x. If, however, we had y squared, y to the fourth power, y to the sixth power, and so on and so forth, in other words, even exponents, on the y variable, that tells me no. And the reason why, let's look at it this way. If I had y squared equals x, if I want to solve for y, I have to get rid of that square. And there's something in college algebra that says, well, just any algebra, that says if x squared equals a, then x equals plus or minus square root of a. This is called the square root property. And so what that means for us is if we have this situation, y squared equals x, that means that y would equal plus or minus the square root of x. And here's the problem. What if x equals 1? Well, if x equals 1, square root of 1 is just 1, that means that y is equal to plus or minus 1. And why is that a problem? Well, if that's the case, x equals 1, y can equal plus or minus 1. In other words, y can equal negative 1, and also y can equal 1 at the same time. So both of these are guaranteed to be coordinates in this relation. So the ones would in fact repeat themselves because the negative 1 and 1 for the y value would have to be there. So there you go. That's the reason why even exponents tell you no, while odd exponents will tell you yes. And this, of course, is just a polynomial, so we're good with that. Alrighty, well, I'll see you in the next video. Have fun.